Still there is no response regarding the voice. Once I get the voice, then I can check then I can start the explanation part. Okay. Still there is no response regarding the voice. Once I right. Get yes. The voice, then I can check. Okay, guys. Yes, I'm getting this now nicely. Right. So here the question is, you can see the question is shown in figure. Here is a convergent lens placed inside a cell filled with a liquid. The lens has a focal length plus 20 centimeter when in air, and its material has refractive index 1.5. If the liquid has refractive index 1.6, the focal length of the system is so what you have to understand is, this system is identical to a lens, a combination of three lenses. What is that? Try to understand here. So it is given that this is the cell, you can say rectangular cell. In this, a convex lens is placed, a thin convex lens is placed. Okay, a thin convex, the lens I may not be drawing properly, so yeah, a thin convex lens is placed and it is filled with a liquid. Right, this is identical to, you have to understand that this part, left side part, this part acts like one lens. What is this can be called as? This is acting like one lens, that is a what is this lens is called as plano concave lens. And then in between a convex lens is there, so we have to consider that convex lens plays its converging role. And the remaining part, yes, this part will act as another lens, another concave lens. Okay, so you have to understand that this is acting like one convex lens, concave lens. Then this intermediate part, we have to understand that it is acting like a convex lens. Then this outside part acts like another plano concave lens. So it is identical to these three lenses. Then the thing is done. It is given that focal length, both are having what is given here? Focal length is given, radius of curvature is given or not? So the refractive indices are given. Focal length is also given. Yeah, the lens is having a focal length of 20 centimeter. Right. So when it is in air, for the focal length to be 20 centimeters, what are the values of R1, R2? You have to understand that here. So this is, I can take it as F1, focal length of this part is F1, the second part is F2, and third part is F3. The effective focal length can be taken as 1 by F is equal to 1 by F1 plus 1 by F2 plus 1 by F3. So here the lens is in air, its focal length is 20 centimeters means we have to say, you have to understand that these two are having same what do you call, they're not biconvex lenses, equiconvex lens. So that means radii of curvature r and r are same, you can say, and its curvature will be having radius of curvature r, and this curvature will be having radius of curvature r. So for in this second one, the convex part can be taken as 1 by f2 is equal to mu minus 1 into 1 by r minus of minus 1 by r, because you have to take this as plus, this as minus. Okay, r1 is equal to plus r, r2 is equal to minus r. Yeah, so 1 by r, from the general formula, 1 by r1 minus 1 by r2, if you can write it as mu minus 1, yeah, as mu is when it is in air, the refractive index is how much? 1.5 minus 1 into 1 by r minus of minus plus 1 by r. Why plus? You can write otherwise clearly, minus of minus 1 by r is plus 1 by r. It becomes 1 by r plus 1 by r is 2 by r. So 1.5 minus 1 is 0.5 into 2 by r. So 0.5 into 2 is 1, so it is 1 by r. So 1 by f2 is equal to 1 by r. This implies r is equal to f2, that is nothing but 20 centimeters. Right, done. Now we can find out f2 is okay, fine, but if you know f1 and f3, then you can get effective focal length. How to find out f1? So here, to find f1, 1 by f1 is equal to, because f1 is focal length of this plano-concave lens, is equal to mu minus 1. Here mu is refractive index of this part. This part is mu of liquid. Act like this, liquid part act like a lens. So refractive index of liquid is refractive index of plano-convex lens part. Here material of the plano-convex lens is nothing but liquid. So refractive index of liquid minus 1 into 1 by r1 surface is plane surface, radius of curvature should be infinity, minus for the other surface radius of curvature is yeah, plus 1 by 20 for right side, plus 1 by 20. So minus of plus is minus 1 by 20. On simplifying this, refractive index of liquid is given as 1.6. Right, on substitution you can write it as 1.6 minus 1 is 0.6 into minus what is this, minus 1 by 20 minus 1 by 20. So you can write it as you can cancel out what you can cancel, it is equal to minus 0.6 by 20, or if into 10 by 10 if you do 6 by 200 or minus. So 1 by f1 is equal to minus 3 by 100. You can take this is different equations you can take. This is general equation 1, this is effective focal length, what you were supposed to find. This is 2, this is 3, 1 by f3 you want, and 1 by f3 is equal to, again, mu l minus 1 into for f3 left side surface is concave and right side surface is plane. So 1 by left side, so minus 1 by 20 minus 1 by infinity will give you, again, this is mu l is 1.6 minus 1 into minus 1 by 20. This also will give you the same as 1 by f1, so it is 1 by f3 is equal to minus 3 by 100. Equation 4, they're equal, same. So therefore equation 1 implies, what is equation 1? This one, effective focal length of the system, that is what you're supposed to find. This is this implies 1 by f is equal to 1 by f1 and 1 by f3 are same. So these two parts you can write it as 2 by f1 or 2 by f3. So 2 by f1 plus 1 by f2 right, it is equal to 2 by f1. 2 into 1 by f1 is minus 3 by 100, right, plus 1 by f2. So 1 by f2, 1 by f2, f2 is 20, 1 by 20 plus 1 by 20. So what you can get on simplifying this, so this is equal to 1 by f is equal to so you can write it as 2 ones 250 is 3 by 50 plus 1 by 20, and simplifying it you will get minus 1 by 100. With that 4, f is equal to minus 100 centimeters will be the effective focal length of the system. This is how you have to do it, guys, right? I hope it is clear. You can go through once again clearly. Now I'm stopping the session. Go through step by step once again. You can pause and you can note down and try to understand.